Okay, so this handout will actually go in your notes for bisectors of triangles. Uh, and they talk about several things in this section. One is a perpendicular bisector. It might be a perpendicular bisector of a line segment. It might be a perpendicular bisector of a side of a triangle. In this it says in a triangle, a line, a segment, or a ray that passes through the midpoint of a side and is perpendicular to that side. So if you look at your handout, if you look at this line, I'm taking BC and bisecting it, and it's perpendicular to BC. So it makes this a right angle, and if it's a bisector, then these two parts, BD, is congruent to DC. You might want to put that out to the side, okay? BD is congruent to CD because it's a perpendicular bisector and D is the midpoint, okay? Okay, theorem 5.1 is the perpendicular bisector theorem. It says if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. Okay, here's the segment that I was drawing. Okay, the segment was AB. If you bisect that and it's perpendicular, pick any point. I don't care where you pick the point. I pick point C. Then that point C is equidistant, okay, from the two endpoints. Okay, if I picked a point D and put it up here, okay, it would be equidistant, like this would be equal to this. That makes sense? So if CD is the perpendicular bisector of AB, then AC is equal to BC. Okay? And I've already marked it that way. Plus it's also these AD and BD are equal also. Then you can go the other way. Okay, the converse of the perpendicular bisector theorem. Okay, the converse of that says if a point is equidistant, okay, like if they gave you this point and said it's equidistant from the two endpoints, then that means that point C has to be on the perpendicular bisector. Okay? Everybody okay with that? That's not too bad. Okay, then they talk about concurrent lines. Okay, concurrent lines, three or more lines that intersect at a common point. Okay, so three lines that intersect at a common point. And the point where they intersect is called the point of concurrency. Okay? Now, there are some special names for centers of triangle. The first one that we're going to talk about is the circumcenter. It's the point of concurrency of the perpendicular bisectors. And it's equidistant from the vertices of the triangle. So first, on this drawing, I want you to look at the perpendicular bisectors. If you look at like BC, okay, this line where it shows the right angle, that's the perpendicular bisector of BC, and the midpoint's F. If you look at this one, look at AB, and the perpendicular bisector, okay, of AB is this line, okay? And then if you look at AC, and the perpendicular bisector is this line, okay? Now, the point where all three of those intersect, this line, and this line, is called the circumcenter. So, out at the side, label that. Point P is the circumcenter. Okay, then the last sentence in that definition says it is equidistant from the vertices of the triangle. So take that point and draw a line segment to, I think it just barely shows up on your drawing. If you need to draw it darker, draw a point from the circumcenter to the vertex of the triangle, from the circumcenter to the vertex A, and all three of those you need to mark them, those distances, like, and I would put it outside. Like BP is equal to AP is equal to CP. Okay? Write it out here at the side. BP is equal to AP is equal to CP. Okay? And I drew you another picture over here, same thing. So this one would be the circumcenter. Okay? And this one actually has the vertices, the distances. These would be equal. Okay? And if they did not extend, if I extended this one on out, this line is the perpendicular bisector. Okay? Okay, and this one is the perpendicular bisector. If you extend it on out, this would be a right angle, and this would be a right angle. Okay? Okay? So that's the first center that they're going to talk about. Okay? Then they talk in theorem 5.3, the circumcenter theorem. It says the perpendicular bisectors of a triangle intersect at a point called the circumcenter, and that's equidistance from the vertices. And I guess that's what we just wrote up there. Okay. Okay. Everybody okay with that one? Okay. Go to the next page. Now, angle bisector. We're going to look at angle bisectors, and then we're going to go to triangles. An angle bisector, remember, it can be a ray, it can be a segment, or it can be a line that bisects an angle into two congruent angles. So if I'm looking at this whole angle, like angle ABC, this ray BD is the angle bisector. Okay, so I should have already marked those two angles. This angle ABD is congruent to DBC. Okay, those are equal. And theorem 5.4, the angle bisector theorem, if a point's on the angle bisector, okay, that looking at point D, then it is equidistant from the sides of the angle. Now, the critical part to that statement, when they say it's equidistant, is it has to be a right angle. When you say, okay, take D and draw the distance back. Remember when we did the distance earlier before break? Okay, it had to be perpendicular. And this one has to be perpendicular. So make sure those right angles show up. And that means AD is equal to CD. Okay? Okay, then theorem 5.5, the converse of the angle bisector. If a point is on the interior of an angle, is equidistant from the sides of the angle, then it is on the angle bisector. Okay? Okay, the second center. The first one was the circumcenter. The second one that we're getting in this section is what they call the end center of a triangle. Okay? The end center. It's the point of intersection of all the angle bisectors. Okay? So, take this angle and bisect it. Okay, here's your angle bisector. Okay? Take this angle up here and bisect it. And this angle and bisect it. And then the point in the center, okay, where those meet is called the end center. So let's label that. Say point A. And then outside A is the end center. Okay? It's the intersection of all the angle bisectors. And that's defined up above. Okay? Okay, then theorem 5.6, the end center theorem. The angle bisectors of a triangle intersect at the point that's equidistant from the sides of the triangle. Okay? So, it means that they all have to be equal. Okay? Now, you got to look at this. This picture up here, it does not, like, these are up here are not equal. Like, let me erase this one. If I look like this distance to the this is not the same as this. Those are not equal necessarily. Okay, what you have to do is do the perpendiculars. So that's why I drew it in on another drawing. You know, here's the angle bisector. Okay, here's the angle bisector. Here's the angle bisector. They intersect at the end center. But that does not mean, okay, like that those are equal. You have to do the perpendiculars. If you take the perpendicular distance from the center to this side, okay, make sure that's shown on your picture and make sure it's a right angle. This would be a perpendicular, okay, make sure it's a right angle, and this one's a perpendicular. Because when you do the distance, it's perpendiculars. Now, those three are equal, okay? Okay? So, example, one example, and you can write this on there, sketch down at the bottom if you want to, or you can just watch. On this one, the properties of angle bisectors. So if they gave you, it's an angle bisector, you can tell because they're giving you two angles that are congruent down here. Okay, and it's perpendicular distance. So what do we know about these two distances? They're equal. So if you were going to solve this, you would solve it 4x minus 2 equals 6x minus 8. Okay, and when you have the variable on both sides of the equal sign, you got to get them together. So subtract 4x on both sides. You do have to keep track of the signs. You can't just drop off that negative sign. Okay, and you'd have 2x minus 8. Add 8 to both sides. Because I know some of you on the test dropped off a sign and that messed up your answer. So, and this would be, you got to work with positive and negatives and then divide. So you should get x equals 3. Okay. There's a lot of terminology, vocabulary in this section, but don't make the problems hard. I'm going to let you look at the examples out of the book, okay, and then the assignments up on the board, okay? Okay.